Okay, a relation is simply a. Let's define what a relation is, what a function is, what a constant function is, and what a one-to-one function is. Okay, uh, a relation is simply a mapping of inputs to outputs. So, for example, here, if I had this little circle here was represented my set of inputs, and this in here was my outputs. So I have 1, 2, and 3, 4, 5, and 6. A relation is simply a mapping of inputs to the outputs. Okay. A function is a particular type of relation where each input maps to one and only one output. So if I had something like this here, each input maps to only one output. So each input will go to one output. Okay. Here's another case here. In this case here, each input maps to the same output, but each input is mapping to going to only one output, not to two. Okay. Now, a constant function is a function where each input maps to the same output. So 1 could map to 5, 2 could map to 5, and 3 could map to 5. All of them are mapping to 5. A constant function where each input maps to the same output. A one-to-one function is a function where each input maps to only one output, and if we reverse it, each output maps to one input. For example, if we map hx to a y, you see that it's still a function. And if we map it back, each y maps back to 1x. Still, that is still a function. This is a one-to-one function. This is a one-to-one function here. So by definition, if we map it back and it still goes, each output goes to one input, and it's still a function, it's a particular type of function called a one-to-one function. And there's other sub-definitions on this too. Okay. So now, what the strategy here is to use these definitions and see if these relationships hold for according to the definition to find what kind it is. So when we look at one here, A, each state's governor. Okay, let's look at A. Each state to governor. States to governors, is that a function? They see the states are the inputs and the outputs are the governor. So I'll have states here. And governors here. So each state has one governor. Each state doesn't have the same governor, but each state has one governor. So you see that it is a function. Is it a constant function? By definition, it's not a constant function because each input would have to map to each state would have to have the same governor. So it's not a constant function. Okay. Is it a one-to-one function? If we map it back, we see that each governor has one state. So it is a one-to-one function. So let's look at B now. They let the inputs be the governors and the outputs be the states. So if you look at this, we see that each governor has one state. Each governor has one state. Okay. So yes, this particular type of relationship here is a function. Is it a constant function? Does each governor have the same state? No. Is it a one-to-one function? So if we map it back, we see that each state has one governor. So it is a one-to-one function. And for C here, you have people at a concession stand. So you have the people here for my inputs. Then the outputs are the cost. So when the people are in line and in line to buy something, so does each person have a cost? Yes, each person will have something that'll cost something. So it is a function. Each person has their own cost. Then ask the question, is it a constant function? Is each person have the same cost? No, because some people may order something different, so the cost will be different. So it's not a constant function. Each person doesn't have the same cost. They're not ordering the same thing. Okay. Is it a one-to-one function? Now, in this next scenario here, is this a one-to-one function? So look at it from this point here. So this person gets something that costs $4, and this person gets something that costs $4, and this person gets something that costs $6. I'll take that out. So you can see here that it is a function. Okay. It's not a constant function because they're not ordering the same thing. And it's not a one-to-one function. Because if I tried mapping this back, the 4 would map back to 1, and it will map back to 2. So it's not a one-to-one function in this case. Now let's look at another one here. And in this one here, they reversed it. They have the cost, and then they have the people. Okay, so you have the cost here, the people. So it's possible that one person, 2 people may order the same thing. So you map back the cost. These 2 people here can both be buying something that costs $1. So you map the cost back there, there. And there. So when you look at this one, another point, this would be people here. These 2 people order the same thing, and this would order something different. So you can see here that it's not a function. It's not a function. It's not a constant function. Everybody didn't get the same thing. And is it a one-to-one function? It's not going to be a one-to-one function either. Because if we map it back here, we have this 4 and the 5. It's not going to be a one-to-one function. Okay. Because with a one-to-one function, each input maps to one output, and then that output maps back to the input. And it's still a function. So it's not a function in the beginning, so it's not going to be a one-to-one function either. Let's look at E here. Now with E, students at a college and a mascot. So we have the students and a mascot. So the students at the college will all have the same mascot. The students at the college all have the same mascot. Is it a constant function? Does each student have the same mascot? Yes, it is a constant function. Okay. Is it a one-to-one function? No, it's not. If we map it back, we see it fails. Although it's a function one way, it's not a function both ways. So it's not a one-to-one function.